today's video we're going to look at section 5.3 and this is basically just going to be two different types of examples that you will see in this section. It's looking at different types of Venn diagram problems. So the first type of problem is where you are given the Venn diagrams completely filled in with the number of people or things in each particular set already filled out in the Venn diagram, and they will ask you to pull information from that Venn diagram. The other type of problem that you may see, which is this one that we'll go through, is where they give you this information and ask you to actually draw the Venn diagram and fill the Venn diagram in with all the relevant information. So we're going to start out with this problem here. We're looking at Nobel Prize winners. They've told you that the universal set of people that we are looking at is Nobel Prize winners during the period 1901 to 2015. And then they've got three different subsets from that universal set. The first one is any American Nobel Prize winners, so they could have won any one of the Nobel Prizes, but it's just the ones that are American. Then they've got anyone of any nationality that won the chemistry Nobel Prize. And then they finally got the subset of people that won the Nobel Peace Prize. And they've got this Venn diagram that shows you how many people fall into each set and how many people fall into the intersection of some of these sets. So for example, we know, just as one particular set of people here, the people that won a chemistry Nobel Prize that were American would be the 69 people, but there is also that one extra person in the middle that not only were they American and won the chemistry Nobel Prize, but they also won the Nobel Peace Prize on top of that. So the number of people that were American and won the chemistry Nobel Peace Prize would actually be 70, because there is that additional person that also won that Nobel Peace Prize as well as the chemistry Nobel Prize, and they were American. Okay, so we have to really study these and see what that intersection between these different sets would be in order to pull out the information. So let's look at the problems that we have been given here. First question is, how many Americans received a Nobel Prize during this period? Okay. So how many Americans? Well, the Americans that won this, any type of Nobel Prize, would be anyone that fell into this circle. Okay, so the answer to A would be all of those values added together. So it would be 249, that's just the number of Americans that won a Nobel Prize, but it was not chemistry and it wasn't a peace prize. Okay, then there are the 69 people that were American and won a chemistry Nobel Prize, but not the Peace Prize. And there were the 26 that won the Peace Prize, but not the chemistry. And then there was the one that was American and actually won both of them. And if you add all of those together, you should find that you get 345. The next part asks us, how many Americans received Nobel Prizes in fields other than chemistry and peace during this period? Okay. Well, we know that we're only looking at Americans here. So again, we're looking at that same circle, but we want the number of them that won a Nobel Prize that was not chemistry and was not peace. What we are technically looking at here is the set of Americans intersected with those that are in the complement of the chemistry set, intersect those that are in the complement of that Nobel Peace Prize set. So we are looking at all Americans that did not win a chemistry or Nobel Peace Prize but did win one of the other Nobel Prizes. So we are just looking in this area here. So we are looking at that 249 people. Okay, so this is how we pull that information out. Part C asks us how many Americans received the Nobel Peace Prize during this period. Okay, so it's the number of Americans again, but this time we're looking at the Nobel Peace Prize. So we're looking at the intersection here, but we also have that additional person again that also was not only American and won the Nobel Peace Prize, but they also won that chemistry prize. So our answer to C would actually be the 26 people that were American and just won the Peace Prize, plus that one that won both of them. So that would be 27. And finally, we have how many Nobel Prize winners were there during this period? Okay. This means that we need to find out how many people are in our universal set. We want the number of people that fall into that universal set that we are looking at. So all you would do here is add all of these numbers together, and that would tell you in total how many people won Nobel Prizes in that particular period. So D would be all of these numbers that you see within your universal set. And it actually comes to 900. Okay. So what we have done here is we have looked at a Venn diagram and we have been able to pull some information off of it. My recommendation to you is, and this always happens with these problems, don't forget the person or objects that are in the very middle, that are the intersection of all the sets. Because a lot of times, especially like where we looked at part C here, where we looked at the number of Americans that received the Nobel Peace Prize, our temptation is to go with 26. But we do have that additional person that he was American and won the Nobel Peace Prize, but additionally also won that chemistry prize. So please keep that in mind. With some of these problems, don't forget to look at the intersection of all the sets at that middle number. The next problem that we're going to look at is the other type of problem that you can get, where you're given a bunch of information and you have to then draw the Venn diagram. My advice to you with these problems is to work from the inside out and to work backwards. So whenever they give you all of this information, look at the number of people that fall into the middle set, so the one that's the intersection of all the sets, and then work your way out from that. So here we have this advertising agency, and they've looked at the kind of media that is used by the 170 clients that it has. So we've got how many people use TV, how many people use internet, how many people use mobile apps, etc., and who's in the intersections of each set. The problem is, and this is why I'm saying to work from the inside out, the 70 people that use all three are also included in the 95 that use the internet and mobile apps. 70 of the 95 actually also use TV as well. They do use internet and mobile apps, but they also use TV. So they're also included in that very middle part. So the people that just use internet and mobile apps would actually be 25, because 70 of the 95 use all three, so 25 use just internet and mobile apps. So you have to be careful with these, and that's why I say to work from the inside out, is because that middle number has to be taken away whenever you start looking at these intersections. So we start out with our universal set of 170 people, so we'll draw that out as this. We'll call it U for the universal set. I then have the people that use TV, that's going to be one part of my Venn diagram. Then I've got the people that use internet, that's going to be another part. And then I've got the people that use mobile apps, that's going to be another part. And like I said, work from the inside out. So we know that there are 70 people that use all three. So I'm going to put 70 in the middle. Okay. Then we'll go with the top intersection here, the TV and the internet. Okay. Let's go back to our problem here. It tells us that there are 75 people that use television and the internet. Well, 70 of those 75 actually use the mobile apps as well. They use all three. that tells me that only 5 people use television and the internet, because the other 70 use all 3. So I know that I'm going to have a 5 in there. And you keep going like this. So then let's look at internet and mobile apps. So it tells us that 95 use the internet and mobile apps. 70 of those use the TV as well. So that leaves me with 25 people that use the internet and mobile apps only. And then we want to look at the number of people that use the TV and mobile apps only. So we know that there's 85, but 70 of the 85 use all 3. That leaves us with 15 people that just use TV and mobile apps. Okay. Then we look at these larger numbers here. So we know, let's start with our mobile apps. 130 use mobile apps. So I know in total in my mobile apps circle, I need 130 people. Okay. Currently, I have 70 plus 25 plus 15. That's 110. So I've got 20 people left that just use mobile apps. They don't use TV, they don't use internet. I just have 20 people that use just mobile apps. Okay? And so in my circle now of mobile apps, I have 130. Then 100 use the internet. So if I look at my internet circle here, I've got 5 plus 70 plus 25. That's already 100. So I have no one, there's 0 people that use just the internet. And then I have 115 that use television. Well, so far I have 70 plus 15 plus 5. That gives me 90. So that leaves me with 25 people that just use TV. Okay. So now we filled out our 3 subsets and their intersections. The issue is we were told at the start that we have 170 people in total, 170 clients in our universal set. So there are some of these clients that this advertising agency has looked at that don't use any of these 3 types of media. Okay, they don't use TV, they don't use internet, and they don't use mobile apps. So they're still in my universal set, they're just not in one of my 3 subsets here. So what you have to do at this point is add together all the numbers that we have. So 25 plus 5 plus 70 plus 15 plus 25 plus 20 and then plus 0 that we had in the internet. When you add all of those together, you should get 160. Okay. Well, I had 170 clients in total. That tells me that I have 10 people that don't use any of these 3 types of media, but are still one of my 170 clients. Okay. So whenever you get a problem like this, work from the inside out in terms of your intersections and work your way out to that whole universal set. And remember, when you work your way out, also include the number of people that are not in any one of your subsets, because they are still within your universal set. They are just not in one of your subsets. These are the 2 types of problems you can get. So it's either like our first type of problem, where they will give you the Venn diagram and you have to pull the information from it, or it will be where they give you the information and they will ask you to draw this Venn diagram. So you will end up with one of these 2 types of problems.